Hi mathematicians, this is Dr. J, and in this video, our second in a series, we're going to be looking at quadratics. That's parabolas, quadratics. Those are those shapes that look like either an N shape or a U shape. We're going to work out how do you work out the equation of one of those graphs if you can see the graph and you want to know the equation. I'm going to go through two examples, and after the examples I'll show you in a little bit more detail the formula that I used and give you a couple of practice questions, and you can answer those in the comments. So good luck, here we go. Okay, here's our first example of a quadratic. I can tell it's a quadratic because it's got that nice U shape here, or sometimes you get the upside down, the N shape. This is a U shape quadratic. I know I'm going to use this formula down here on the right. First thing I always look at is the axes and see what letters they're using, and the letters they're using are an M here and a T here. So I'm going to come down on the right here, and instead of y equals, I'm going to put M equals. I'm going to skip the scale until I get to the bracket, and instead of X I'm going to put T, and I'll close that first bracket, next bracket, T, like so. I don't know the other parts yet, but I know we're dealing with the letters M and T. Next thing I'll do is these intercepts, the first and the second x-intercept, or t-intercept in this graph. Clearly, where does it touch that horizontal t-line? It touches at 4, that's the first one, and at 8, that's the next one. That means I come over to the right and I go t minus 4 and t minus 8. If those numbers on the graph had been negative, that would become t plus something. But here, because 4 and 8 are positive, it's going to be t minus those. Okay, now the thing to finish it off is I need to find the scale. Now the scale is something that you use to stretch it vertically or squash it vertically if it's not the right height that you want. So what I do is I take what I've already got and I check, is that close enough to what we see on the graph by choosing another point. The one that I almost always use is the m-intercept or the y-intercept, the vertical intercept, which here, it's hard to see exactly what that point is, but it's somewhere between 20 and 40, a little bit closer to 40, I would guess about 32 or something like that. What I need to check is, does my formula that I've got already, does it give me a number of just a little bit over 30? If not, I need to stretch. So what do I know about this point on the vertical axis? I know that t is, can you guess? T is not 32, that's the m. T is how far left or right, which is 0. That's a t equals 0 point. So all I do is I take what I've done over here and I'd go m equals, and I just test it out. What happens if I go 0 for t minus 4 times 0 for t minus 8? Plug that into your calculator, you'll find that it equals 32. And that's perfect. That means I don't need to adjust the scale. I'm already getting the right kind of scale. So I can jump straight into the answer. I'm just going to repeat what I wrote above. M equals bracket t minus 4 bracket t minus 8. I'm done. In the next example, we'll have a look at one where you do actually have to adjust the scale. But I wanted to start with one where you don't. Make sure you've got that all sussed. Cool. Our next example. Again, clearly a parabola. We've got, or a quadratic, we've got that nice curve shape. This one's an N rather than a U. It's going, I would say, upside down, the N shape. And we'll see how that affects the scale a little bit later. But for now, first thing to do, let's look at the letters. What are we dealing with? Well, we've got a B up here and we've got a P down here. So I'm going to jump over here and say B equals, skip the scale, bracket, it's P minus something, and then P minus something. But I'll just leave it as P at the moment. Okay, well what goes into those brackets is my horizontal intercepts or x-intercepts, in this case p-intercepts. I'll just mark in where it touches that horizontal line at -10 and 20. That means over here I'm going to put, because the first one's -10, subtracting -10 is the same as adding 10, and then subtracting 20 is just subtracting 20. So notice how we always change the sign of those intercepts. If we have a negative 10, it becomes a plus 10 in the bracket. If we've got a positive 20, that becomes a minus 20 in the bracket. Just flip those signs and you'll always be right. Okay, we're halfway there. We just need to work out the scale. Now, again, just like in the previous one, I need to find another point to check the scale. And once again, I don't have to do this point, but I like to do this point. I like to choose this here, which is the intercept on the vertical axis. What do we know about that point? I know that it's p-value. I can see vertically it's roughly 50, but that's not the p-value, that's the b-value. The p-value is the horizontal position, and because it's on that line, its horizontal position is 0. So that's the p equals 0 point. Now what happens if I take that 0 and I put it into my formula? Let's try that out. B equals, and I put in 0 plus 10 for p, and p equals 0 minus 20. Now if you do that, work out what 0 plus 10 is times 0 minus 20, you're going to end up with negative 200. Okay, now I didn't want negative 200. That has to be scaled. If it went up to negative 200, first of all, it would be going down. I don't want it to be down, I want it to be up at 50. And 200 is much, much too big. I need to shrink it down to 50, and I also need to change it so it becomes a positive. So what's my scale? My scale is going to be, well, how would I shrink it, first of all, from a 200 to a 50? Well, 50 is a quarter of 200. You can work that out by going 200 divided by 50 is 4, so 50 is a quarter of 200. But I also need to flip it so it's an N shape, so that it touches at 50, not minus 50. And so the final answer is going to be using a scale of negative a quarter. Right, the negative changes it so that instead of being negative, it becomes positive. I want it to be positive 50. And the quarter changes 200 down to 50 size. So it's a negative a quarter bracket p plus 10, p minus 20. And we're done. Here's a summary of the formula that I used to work out the equations of those quadratics. It just gives a very simple summary of what I mean by the scale, what x int 1 and x int 2 are. It's probably a good idea to take a screenshot of this so that you could review it later. Guys, thanks for watching. That's the end of that video and how to find the equation from the graph. I'm going to finish with 2 questions that you can try and answer. If you think you know what the answers are, put them in the comments and I'll try and give you some feedback on those in the comments. So thanks for watching. Here we go.